Video, I'm going to explain why UJT is required and we are going to see the applications of UJT. So one of the very important application you can say UJT as a relaxation oscillator. And also by using UJT as a relaxation oscillator, how it can be used as a triggering circuit for the SCR. How I can turn on the SCR at a required interval. So this is the discussion topic now. So let's start with the why UJT. Let me highlight the points one by one. So why UJT? UJT in the last video I had explained about how UJT works, what is the basic operation of a UJT, and what is the importance of VP, peak voltage. Okay, and also the expression related to the VP and all we have gone through it. Now let's look at the application point of view of UJT. Unijunction transistor is often used as a trigger device for SCRs and triac. So in the power electronics, as you know, the vital device is SCRs and triac. Okay. So if you want to turn on the SCR, you need to provide the pulse through the gate terminal. So if you want to turn on the SCR, so you have to trigger the SCR through the pulse. So that particular pulse can be generated from the UJT. So this is the very important application of UJT. UJT is often used as a trigger device for SCRs and triac. So other application includes non-sinusoidal oscillator. So other than sinusoidal, we can generate oscillations. Then sawtooth generators. So in the UJT relaxation oscillator, we are going to see how we can generate this sawtooth wave. So this I'm going to show in the next this circuit. Also, it can be used as a phase control. I can control because SCR by using SCR as the name suggests silicon controlled rectification. So in the rectified output, you can control the phase also. So by using UJT and SCR together, you can do the phase control application also. Then timing circuits also can be generated. The most common UJT circuit in use today is the relaxation oscillator. So the very important topic to be discussed here is relaxation oscillator. So in the exam point of view, you may get the question explain UJT as a relaxation oscillator and also how UJT can be used as a triggering device for SCR. So these are the two questions I'm going to address now. So we just saw the application point of view. Moving ahead, UJT as a relaxation oscillator. So you know the symbol of UJT. I'm going to write it again. So it looks like a kind of a MOSFET at the this two terminal. So this terminal is B1, this terminal is B2, and this terminal is emitter. And the inclination is towards base 1 because once the diode is forward biased, internally emitter junction is formed through the one diode. So you know the internal diagram, equivalent circuit diagram. So once the emitter terminal is forward biased, then the base B1 resistance will vary accordingly. It may vary from 4 kilo ohm to few ohms, maybe 10 ohms. Okay. So let's look at the application point of view of UJT. How UJT can be useful to generate the relaxation oscillator, kind of a sawtooth waveform. So basically, you need to understand at the input side to the emitter terminal, we have connected two R and C component here. R and C components are connected to the emitter terminal. And the two terminals B1 and B2, we have connected two resistors here as a current limiting resistor. And please note that the R1 and R2 is far less than your internal resistor at the base 1 and base 2 terminal, RB1 and RB2. So if I say this is in around 10 kilo ohm, which is nothing but RBB, but this is in ohms, like 100 ohms. The maximum it is in ohms, so very less than compared to this value. Okay. Please look at the circuit diagram here. So if you want to apply the power supply to this circuit, so there is a switch connected here. When the switch is closed, then the supply is applied to this circuit. So till that, your UJT is off and capacitor is initially no charge. It is not charged. So it is empty now. Okay. Once the switch is closed, let's look at the circuit operation. Yeah. The circuit operation can be explained with the two steps here. The first step, once the switch is closed, the first the diagram, this diagram depicts that VC versus T. Okay, so that means the capacitor voltage, how it is going to charge to the maximum EDC, the applied voltage. So let's look into that aspect. The capacitor will be charged through the R here when UJT is off. Please note, initially UJT will be off. You know the VI characteristics of a UJT. UJT will be turned on only when it is beyond VP, peak voltage. Peak voltage is purely determined by EDC, right? And we know that your Vx, that is when UJT is off, Vx can be determined neta times the EDC here. Okay, neta times the EDC. You know what is the intrinsic standoff ratio, and EDC is applied voltage. So it is directly proportional. So based on this, your Vx is determined. Okay, Vx is at this particular node. Okay, and if you want to find out Vp, which is nothing but Vx plus Vd, we know this expression, right? So the peak voltage is very important parameter. Only beyond peak voltage, so your UJT will turn on. So till that peak voltage, the capacitor starts charging through the R when UJT is off state. So that is the first point you have to observe here, and which is shown in this graph. That is VC versus T. So now your capacitor is charging now through the R when UJT is off, and when it reaches to VP, when it reaches to the peak voltage, because all the applied the charge stored here will apply to the emitter terminal, so then UJT will turn on. So once the UJT turn on, it will stop charging. So then what happens when UJT is on, capacitor discharges, which is shown in the this waveform, VC versus T. It charges up to VP. You may observe here VP. So then it starts discharging. So the discharging period will be very quicker because of internal RB1. So it discharges through RB1 and R1, which is very short period compared to 0 to T1 interval. Okay, so if you look at the charging period and the discharging period T1 to T2 is very quicker than the charging period. When it discharges below VV, that is a valley point, you know the VI characteristics, below the VV, immediately UJT turns off. So in this, when it below the VV, UJT turns off. So when it turns off, now there is an opportunity for the capacitor to charge again, right? So in this way, the cycle repeats. The step 1 and step 2 continuously will happen. As a result, periodic sawtooth type waveform is generated. This type of waveform will be generated. You may observe in this graph. So the train of sawtooth wave, discharging and discharging happens, and it is going to be repeated. Okay. As a result, so the one more very important observation here, and when UJT is on, the discharging will be seen like this. So it looks like a small short pulse, short train pulse. So if the output is taken from B1 terminal, the result is train of pulses occur during the discharge of the capacitor through the UJT emitter. So when the UJT is on, so this can be observed. So how the discharging train of pulses will be seen as a output pulses. So this pulse is very important for me for the next application. So what is the next application? Let's highlight that. So the next application you may observe here, UJT oscillator as a gate trigger source. So we have two devices now. So the one is your UJT unijunction transistor. The other one is your silicon control rectifier. So if you want to turn on this particular SCR, so you need to provide a proper pulse through the gate terminal. So how we are going to connect that? A very simple connection. So this is a UJT setup. So I'll just mark it here. So this is UJT oscillator, and we have here SCR setup. Okay. So the supply is applied to both UJT relaxation oscillator and as well as SCR. But SCR initially in the through the RL, so it is initially open because unless we provide a proper pulse through the gate, so it acts as an open circuit. Okay. So now once the switch is closed, your charging and discharging happen based on UJT on and off. So then accordingly, if you tap the signal from the B1 terminal, you are going to find the train of pulses. So that pulses are applied to the gate terminal for the triggering as a triggering source to the SCR. So you may observe here positive pulses of UGT B1 terminal are often used to trigger SCR. The first B1 pulse triggers or turns SCR to on state. The first pulse itself, we don't need train of pulses. The first pulse itself will make the SCR to turn on. Once the SCR is on, the subsequent pulse at its gate have no effect. You know that once it is on, gate loses its control over SCR. So in this way, we can understand the UJT, how UJT is useful for triggering the SCR and triac and some other application also you may observe. And UJT relaxation oscillator is very simple to understand. So you need to observe the charging and discharging of the capacitor. When UJT is off, it will charge. When UJT is on, it is going to discharge. So that creates a sawtooth waveform. Okay. Hope you understood about the application point of view also. Thank you.